Welcome to the distance learning packet for IM2. This is week 5. In this video, I am just going to show you the notes and a couple of practice problems on how to factor using the GCF, which is called the greatest common factor. On the screen here, it asks you what is a factor, and a factor is a number means to break up that number that can be multiplied together by the original numbers. It's not going to make sense until I show it to you. So let's take a look. We know that this number 6 can be broken up, can have factors of what? 1 times 6 equals to 6. So this is called a factor. This is called a factor. And this is of 6, right? What else is also a factor of 6? You would also say 2 times 3 is also equals to 6. So you would say 2 is a factor and 6 is a factor. So if I say 6 can have factors of, in simple terms, 1, 2, 3, and 6. 1, 6, 2, 3. I just wrote it in order. Okay, notice how I can break that up. What about if it's like a polynomial? Let's say it's a squared plus b cubed. If you write this into expanded form, it looks like a times b times b times b. Okay? These are all factors of this. Likewise, you can have a polynomial that looks like this. Okay, we call this, you should remember this earlier, we call this standard form. And how did we get to standard form? Okay, we multiplied x plus a number and this. So we had something like this. And we multiply these two together by foiling and we got the standard form. Okay, so let me show you on the side. So you had x plus 1 times x plus 2, correct? If you FOIL, it becomes x squared plus 2x plus 1x plus 1x, 1 plus 2, so 2. So x squared plus 3x plus 2. Notice this is referred to as the process of multiplying. Okay? If we go from backwards, from here to here, we call this factoring. Okay, so you would say 1 is a factor, and you would say here 2 is also a factor. Okay, the first thing that we should talk about, so this is the definition of factor. Okay, now let's go over this definition of what the greatest common factor is. The greatest common factor, you might have seen this in as G. You might see this as GCF. Okay? If I asked you for the greatest common factor of, let's say, let me give you this example of the number 15 and 45. Okay, watch how I can break up 15. I could break that up into, let's say, 3 and 5. Okay, 45 can be broken up into 9 times 5, and 9 can be broken up into 3 times 3. Okay, notice the numbers that I have left here is 13 and 5. Okay, so if you look about what numbers multiply to 15, it's 1 times 15 is equal to 15, correct? Here, what can also multiply to 45? 1 times 45. Then we see here, it can also be 3 times 15 and 9 times 5. Notice that the 15 and the 15 here are the same. So you would say the GCF of 45 and 15, the GCF is 45. Okay, you should remember this from your elementary school days. Okay, that's where you should see GCF. But let's see what happens when you have something like this number. When you have 2x squared and you have 4x5. First of all, you want to write out the number out, okay? So 2, that is really 1 times 2 and times, you have x squared, right? So you have x times x. Good? Then here you have 4x to the 5th power, right under it. So 1 times 2, 1 times 2 is 2, times 2, that makes 4, times x times x times x times x times x. 1, 2, 3, 4, 5. Okay? So this was what 2x squared was equal to, and right here this is what 4x5 was equal to. All right, look at the numbers that they have in common. Ready? They have the number 1 in common. Sure, 1. They have the number 2 in common. 2. Multiply 2. Do they have any other 2's? No. Then they have this 1x in common. Then they have this other x in common. So this becomes 1 times 2 becomes 2. X times x becomes x squared. So the GCF is equal to 2x squared. Okay, if you follow, this is called the vertical method, where you stack it on top of each other and you collect which one they look the same. That's an easy way of how to get the GCF. So this is how to get the GCF. So let's look at some examples. The first one, you have this polynomial, 2x squared minus 4x plus 8. Let's look at the GCF, okay? So what is the GCF? That's the question. What is the GCF, the greatest common factor? The number that we want to look at is 2, 4, ignore the negative, and 8. All right, so let's just write it out. You have 2, 4, and 8. 2 can be written as 1 times 2. 4 can be 1 times 2 times 2. And 8 can be 1 times 2 times 2. That's 4 times 2. Good. Now you want to collect what they have in common. 1, these 2 times 2. Anything else? Nope, that's it. So this equals to 2. You would say that 2 is the GCF. Okay? What is the purpose of finding the GCF here? Once you have the GCF, now you can factor it. So you're going to look something like this. 2x squared minus 4x plus 8. Okay? You're going to pull out a GCF of 2. So you're going to pull out a 2. Then there's going to be parentheses. What do you have left over? What do you have left over here? You have a what? What number do you have left over here? Technically, there's a 1. No one writes this, though. There's a 1 here. So there's a 1 here. 1 left. Okay. X squared. What is left here? What is left here is a 2. So what is left here? It says it right there. Negative. Do you see that negative? What number is left? A 2. So it's 2. Then it's x. Then it's plus. Last one, what is left? What is left? What is left is a 2 times 2, which is 4. So that is plus 4. There you go. This is how to factor using the GCF. Good. That's it. Let's do one more example. So you have this number. Let's figure out what numbers that we are going to find the greatest common factor. So find the GCF. So take a look. You have the number 30, the number 5, and the number 25. So let's just write that out. 30, 5, and 25. Break it up. 30, it equals to, you could always start with 1. 1 times, let's say, 3. Okay, always use prime numbers. So I could do times 10 here, but 10 isn't a prime. You want to break it down. I think 10 can be broken up with 2 and 5. Do you see how this is in a horrible order? I can go, let's say, times 2 times 3 times 5. Okay, I just wanted to write it in order. Good. Next, 5. Okay, so I'm just gonna write the 5 here to give it more room. Here, 25. You have 1 times, I'm just gonna write the 5 under this. You're gonna see why. Times 5. Okay, so I just wrote it so it's in order. Good. And there's a 1 here, of course, right? Times that times this. Okay, now if we find the GCF, we look at what they have in common. So there's a number 1, and this is the reason I wrote it in order, so you can just see the 5. Good. So you could say the GCF is 1 times 5, which is what number? Just 5. So if you factor it, you should get what's left. Let's take a look. Here you have the number. Here's the original problem. 30x cubed times plus 5x squared minus 25x. Pull out the GCF, which we said it was 5. So 5 parentheses. What is left here? What is left? Okay, so it should look something like something x cubed plus something x squared minus x, and we're going to close the parentheses. What else is left after we pull this number out? So from the number 30, do you see how the number 30 was the first spot? What is left? A 2 and a 3. So 2 times 3 is a 6. What is left here? Well, we don't really see it, but there's really a 1 here. If you don't see it, it's really times 1. There's a 1 left here. What's left here? Well, there's a 1 times 5, so that's a 5. Okay, that is what's left here. So this, think about these are the, in math terms, these are the coefficients that are left, right? These are the number that is left once 5 is factored out. Okay, so they pull out a 5. You see how if they pull out a 5 from 30, it becomes 6. They pull out a 5 from 5, it becomes a 1. You pull out 25 by 5, it's a 5. You could also think about it dividing. You're like, what's 30 divided by 5? 6. What is 5 divided by 5? 1. What is 25 divided by 5? 5. Good? That should make sense to you, right? Now I would like for you to try this problem. Okay, I'm going to bring it up. All right, please take this time to finish the problem. All right, I'm going to go over the answer. Factor 5x squared plus 15x plus 10. Here's the solution. Notice that the GCF, greatest common factor, between 5x squared, 15x, and 10, the GCF of that is the number 5. Notice they factor out the GCF of 5. Then they factored out this into here. I'm going to show you how to do this later. At that point, you are done. So this polynomial in standard form can be factored out to be 5, and then the rest of these terms. Good. This is a perfect example. I'm going to show you how to do this later on. All right, there you go. Those are all your notes on how to factor using the GCF.